Hello, myself Amol Dilip Kale, Assistant Professor, Department of Chemistry, Swami Vivekananda Senior College, Mantha, Taluka Mantha District, Jalna. Today, I am going to introduce what is buffer solution, types of buffer solution, what is acidic buffer, what is basic buffer, and their mechanism. Now we have to learn firstly what is buffer solution. The buffer solutions are used in industrial and biological process, and these buffer solutions are made up from weak acid, weak base, and it's a salt with a strong acid and strong base. By this way we can prepare the buffer solution, and this buffer solution in will help to maintain pH constant. So we can define the buffer solution. It is defined as the solution which maintains pH fairly constant even addition of a small amounts of acid or base. Whenever we add small amounts of acid or base into the buffer solution, this buffer solution will reduce its pH or it maintain its pH. So these are the two types of buffer solutions: acidic buffers, basic buffers. Let's see acidic buffers. So we can define acidic buffers. Acidic buffers are prepared by mixing the appropriate quantities of weak acid and its salt with a strong base. This is the example of acidic buffers: mixture of acetic acid and sodium acetate. In case of acidic buffer, acetic acid, which is weak acid, and sodium acetate is a salt. And we know very well that acetic acid, which is a weak acid, and it ionizes partially, while sodium acetate, which is a salt, it completely ionizes in water, and both the forms the two types of ion: positively charged cation and negative charge called anion. Similarly, in case of basic buffers are prepared by mixing the appropriate quantities of weak base and its salt with a strong acid. This is the example of basic buffers: mixture of ammonium hydroxide and ammonium chloride. Now see in the basic buffers, which is a mixture of ammonium hydroxide and ammonium chloride. Ammonium hydroxide is a weak base and ammonium chloride is a salt. And we know that ammonium hydroxide, which is the weak base, so it partially ionizes, and ammonium chloride, which is a salt, so it completely ionizes. So we can say that those quantities which are partially ionizes, like acetic acid and ammonium hydroxide, they still occurs in the solution due to their nature, while the salt, sodium acetate and ammonium chloride, which is a salt, so it completely ionizes in the water. Now let's see the mechanism of acidic buffers. In the mechanism of acidic buffers, we have to see that how this acidic buffer will maintain its pH whenever we add strong acid or strong base into the acidic buffers. We know acidic buffers are prepared by mixing the appropriate quantities of weak acid and its a salt with a strong base. This is the example of acidic buffers: acetic acid and sodium acetate. Now see equation 1 and 2. The acetic acid ionizes partially from acetate ion and H plus ion. This acetic acid attains the equilibrium. So it indicates that this take at equilibrium indicates that reaction occurs reversibly, while the sodium acetate, which is a salt, and it completely ionizes it to form acetate ion and the sodium cation. Now see equation 1. The pH of buffer solution is given by equation 1 due to the common ion effect. Now, if we add a small amount of HCl, that is a strong acid, into the acidic buffer, so how this acidic vapor will resist its pH, or will maintain its pH constant. Now, if we add a small amount of acid, the acid dissociate to form H plus and Cl minus. Already the acidic buffer contain weak acid and ionizes acetate ion and H plus ions. Means in the solution we have a H plus ion in a more concentration. That means acidity increases or pH increases, but it does not happen here because the H plus ions formed from the HCl will forms acetic acid with the acetate ion, and the H plus ion remains in the solution from acetic acid will attain the equilibrium which forms the acetic acid. So this is in case of HCl. If a H plus ion concentration or pH remains constant, means whenever we are adding HCl into the solution, the H plus concentration 0 in the solution. If NaOH is added, if we add NaOH into the acidic buffers, NaOH dissociate into the OH minus. So this OH minus will take a proton from the weakly ionized acetic acid and to form acetate ion and H2O. So the OH ion concentration in the solution is 0, so indicates that pH remains unchanged. Hence, H plus ion concentration, pH of solution remains unchanged. Now, in the mechanism of basic buffers, we have to again learn how these basic buffers will help to maintain its pH constant. This is the example of basic buffers: ammonium hydroxide and ammonium chloride. Ammonium hydroxide is a weak base and ammonium chloride is a strong salt of a strong acid. This ammonium hydroxide dissociate at equilibrium to form NH4 plus and OH minus, while ammonium chloride, which is a salt, completely ionizes to form NH4 plus and Cl minus. Here equation 1, which decides the pH of the buffer solution. Now see equation 1 and 2, ammonium hydroxide at equilibrium gives ammonium ion and OH minus ion. This indicates that the reaction takes reverse, while ammonium chloride, which is a salt, which completely ionizes to form ammonium cation and Cl minus. How pH remains constant in basic buffers? If we add HCl, if an acid HCl is added, hydrogen ions from acid combine with the ammonium hydroxide and hence pH remains constant. Now see this in reaction, the ammonium hydroxide will take a proton from the strong acid HCl and to form the NH4 plus and water. So neutralization occurs here. If NaOH added, if sodium hydroxide is added, hydroxyl ion react with the ammonium ions to form ammonium hydroxide, which remains nearly unionized and hence pH does not change. So in this reaction, the base from the added which react with the ammonium ions to form weakly ionized base ammonium hydroxide and hence pH does not change. So this is in case of buffer solution. Thank you.